Welcome, viewers. In this lecture, we are going to consider multiple question and answer under the following topics: current produced by simple dynamo, induced current, AC generator, DC generator, alternating current, direct current, transformers, induction coil, electric motor, to mention but a few. But before we continue, I want to use this medium to recognize the following subscribers who took part in our live quiz session, the first live quiz session that we have ever had on this channel. And we have the likes of Chukwuka Divine, a student of the University of Calabar, Computer Science Department. We have Esther Effiong, a student of the University of Calabar, Medical Lab Science Department. Chukwuka Divine had the same point with Esther Effiong, and they were decorated as well. The overall winner of that live quiz competition was Okwa Prosper, a student of the University of Calabar, Architecture Department. You too can be celebrated. We are going to have our next quiz competition on the 7th of September next month, 2024. The quiz competition is just a monthly event. It has come to stay. It will be a monthly event, and it will take place every first Saturday of every new month. Every first Saturday of every new month. The time is 11 p.m. Nigerian time, 11 p.m. Nigerian time. So save that date. Save that date. The venue is here live on YouTube. Okay, so that's how far I can go on this, and let's move down to the order of the day. Our first question here says, the current produced by a simple dynamo is not steady. The current produced by a simple dynamo is not steady because a back e.m.f. opposes the induced voltage. Eddy currents oppose the motion which induces them and absorbs energy from the current. The magnetic field produced by the magnet is not sufficiently uniform. The induced current opposes the motion which causes it in accordance with Lenz's law. The rate of change of flux varies with the position of the coil of the dynamo. The question says the current produced by a simple dynamo is not steady. Why? Because the rate of change of flux varies with the position of the coil of the dynamo. The correct option is option E. Note the following, because this will help us to attempt other questions that we will experience or come across. The induced current in a conductor depends on several factors, namely the rate of change of magnetic flux, magnetic field strength, number of turns in the coil, area of the coil, conductivity of the material, and resistance of the circuit. Next question said, induced current depends on the number of turns in the coil, strength of the magnet, time at which the magnet is plunged into the coil. Which of these is or are correct? A. I only. I only. C. I and I only. D. I only, and E, none of the above. Okay, so the correct option here is option C. This question says, which of the following operations will not lead to an increase in the induced EMF of a coil of wire rotating between the poles of the magnet? Increased by. Which of the following operations will not lead to an increase in the induced EMF of a coil of wire rotating between the poles of the magnet? Increasing the area, strength of the magnet, gap between the poles of the magnet, number of turns in the coil, the speed of rotation of the coil. Which of the following operations will not lead to an increase in the EMF? So every other quantity here will lead to an increase in EMF except option C. So that's the correct answer, C. Which of the following statements about generator is not correct? Which of the following statement about generator is not correct? It can produce direct current. It can produce alternating current. It requires an external supply of energy to rotate the coil. It requires an external supply of current to the coil. It may require the use of commutator. The correct option here is option D. It requires an external supply of current to the coil. Which of the following statements about the generator is not correct? So the rest are correct because generators produce direct current. We have DC generator, we have AC generator. B here says generator, it can produce alternating current generator. In those generators, we have the rest. Other ones, it may require the use of commutator. So the option here, D, is the correct answer. If we are to convert AC to DC, let's see the option that is correct. Number of turns in the coil is increased. The strength of the field magnet is increased. Slip rings are replaced with split rings, or you call it commutator. Coil is wounded on a soft iron armature. Okay, so in the conversion of alternating current dynamo to a direct current dynamo, all you need to do is to replace the slip rings with the split ring. The correct option is C. As we continue, I will show you a diagram that will help you understand this better. Facts about AC and DC current voltages. Alternating current and DC current voltages are types of electrical currents that differ in a way they deliver electricity. So what makes one would say this one is alternating current and this one is direct current is the way they deliver electricity. Alternating current is a type of electrical current in which the direction of the flow of electrons switches back and forth and at regular intervals or cycle. Okay, so this change in direction typically occurs many times. So in alternating current, you see the direction of the electrons switching back and forth, while in direct current, it is not so. Direct current voltage. Direct current is a type of electrical current where the flow of electrons is in a single direction. So in this type of current flow, the DC, direct current, voltage, the electrical current is seen to move in one direction. This type of current is typically found in battery and electronic devices. So look at the figure here. You will see the AC, or you call it alternating current. Look at the figure, how it is. It's moving up and down. Then look at the figure for DC. Direct current is a one-dimensional flow. Okay. Why is it that a transformer cannot be operated with direct current, with DC? Why is it that a transformer cannot be operated with DC? Solution: this is just a direct question and answer. The lack of changing magnetic field. So DC doesn't have a changing magnetic field. The core is saturated. What do we mean by a saturated core? Core loses its ability to effectively transfer energy and cannot handle any additional flux. So the core of the DC is always saturated. The core of the transformer in terms of DC is always saturated. And the next one is energy loss. So greater energy would be lost in the transformer if we should use the DC rather than the AC. Okay, so why is it that a transformer cannot be operated with a direct current? The lack of changing magnetic field, saturated core, and energy loss. Number 7 here says, why is alternating current AC preferred over DC in power transmission? The reason is because AC let me put it this way, it could easily be transformed to high voltage either by stepping up or stepping down, and it requires a low energy for the process, unlike that of direct current. So if you see the transformers, what's the job of a transformer? The job of the transformer is to step up potential difference or to step down potential difference, and this advantage is usually obtained whenever you are using the AC than the DC. Okay, so alternating voltages can be stepped up and or stepped down by transformer, while DC voltages cannot. And of course, using the AC, you have a low energy loss as well. Definition of terms. We just want to throw more light on the following: induction coil and other things we should know on this topic, so that whenever they are mentioned, you have an idea of what it is all about. Let me move this one down. Induction coil, often used in early radio transmission or transmitters and sparkling system. It induces, or it includes, a primary coil and a secondary coil with more windings to amplify voltage. The core is typically iron and enhance magnetic field strength. So the induction coil is used in early radio transmitters and in sparkling systems to ignite vehicles. And then I want to add to this that this induction coil can be used to amplify voltage. That's one use or importance, to amplify voltage. So note that word. The DC dynamo or AC dynamo, in an AC dynamo, slip rings connect the rotating coil to external circuit, allowing for continuous rotation without reversing current flow. It's used in power stations to generate electricity. So the DC dynamo is used in power stations to generate electricity. Or the AC dynamo is used in power stations to generate electricity. Let's go to the next one, the DC dynamo. The commutator in a DC generator reverses the connection of the coil to the external circuit every half turn, ensuring the output is always in one direction, commonly used in battery charging and DC power supply. Okay, so the DC dynamo is used in battery charging and DC power supply. AC dynamo is used in power stations to generate electricity, and the induction coil is used to ignite. It's used in vehicles and early radio transmitters, and it is also used to amplify voltages. Transformers. This comprises of the primary and the secondary windings around the magnetic core. So transformers step up or step down voltage levels. Essential in power distribution, they ensure efficient transmission of electricity over long distances. So we have types of transformers. We have the step-up transformer and the step-down transformer. The step-up transformer, an example is that your stabilizer at home. Most of our electronic devices come with this type of transformer. So even when the voltage is very low, you still have what it takes to watch your television and all of that. So the step-up transformer is one that increases its output, and the step-down transformer is the one that decreases the output. An example is that kind of transformer you see that is mounted along the roadside. That's a step-down transformer. Most of them reduces very high voltages from, let's say, 2400 volts. It will now reduce it to about 240 volts. And even the ones we use in our houses, one example of the step-down transformer is that your charger. That your phone charger is a step-down transformer. If you open that charger, you see a small transformer inside. So that transformer will still come and reduce the 240 volts down to, let's say, 6 volts that you can use to power that your phone power bank, or most of the times what your laptop can carry. So that's an example of the step-down transformer as well. So with time, I would really expatiate on transformers, but in this class, I just came to throw more light on these things and not just to go deeply into them. The electric motor, it operates on the principles that a current carrying conductor in a magnetic field experiences a force. Types include AC motor, which are used in household appliances, and DC motor, which are found in devices like electric cars and machinery. So we have the following: induction coil is used to amplify voltage, AC dynamo used in power stations to generate electricity, the DC generator is commonly used in battery charging and DC power supply, and it makes current to flow in one direction. The transformer helps to transmit electricity over long distances by stepping it up or stepping it down. And the electric motor is used in household appliances in terms of the DC motor, and then they are applied in electric vehicles and machineries. This question says, which of the following devices would be used on its own in a working of the petrol-driven motor car engine for obtaining a high voltage from a low one? A. Induction coil. B. AC dynamo. C. DC generator. D. Transformer. E. Electric motor. The correct option is option A, the induction coil. The DC and AC generator. We want to look at few things about tips about the DC and AC generator. Looking at this figure, it's almost the same thing. So the one by my right is the AC generator and the one by my left is the DC generator. So the AC generator has armature, DC generator also has armature. AC generator has magnets, DC generator has magnets. AC generator has carbon brushes and DC generator has carbon brushes. AC generator has load on it. DC generator, we can as well apply load. So the only difference is in the slip ring and the split ring, or you call it commutator. So every AC generator has the slip rings, while the DC generator has the split ring or the commutator. So this figure tells us that if I am converting an AC generator to a DC generator, all I need to do is to replace the slip rings of this AC generator by the split ring, or you call it the commutator. When you do that, automatically you have converted the AC generator to a DC generator. So if we want to convert the DC generator to AC generator, it means we are going to replace the commutator with the slip rings. Look at the spelling. The spellings are not the same. This is split, slip, S-L-I-P, slip rings used in AC generator. And this one is used in DC generator. Commutator, you call it the split ring. Okay. Alright, so note the spelling and then the pronunciation. Let's look at some multiple question and answer. We have the first set of question and answer and the second set of question and answer, as this will help our subscribers on this topic. What is an AC generator? An AC generator is a machine that converts mechanical energy into electrical energy. A machine that converts mechanical energy into electrical energy. The AC generator input supply is mechanical energy supplied by steam turbines, gas turbines, combustion engine. The output is an alternating electrical power in the form of alternating voltage and current. So the AC generator is a machine that converts mechanical energy into electrical energy, and it usually have the output in the form of alternating voltage and alternating current. How does the AC generator produce electricity? AC generators work on the principles of Faraday's law of electromagnetic induction. When the armature rotates between the magnet's pole upon an axis perpendicular to the magnetic field, the flux linkage of the armature changes continuously. Because of this, an e.m.f. is induced in the armature, which induces electric current through the galvanometer and the slip rings and brushes. Next question. Let me move this. What factor do the generated e.m.f. in an alternator depend on? What factor do the generated EMF in an alternator depend on? The generated EMF depends on the following: number of armature coil turn, magnetic field strength, the rotating field speed, number of armature coil turn, the magnetic field strength, and the rotating field speed. Please note the following. What are some advantages of AC over DC generators? We have already stated that, so those ones will help us to answer this question. AC generators can be easily stepped up and stepped down through transformers, unlike DC, so that becomes an advantage. Losses in AC generators are relatively lesser than in DC machines or DC generators, so energy losses are less in AC generator than how it would be in a DC generator. Let's consider this as well, the second side of still question and answer on this topic. What is the primary difference in the output of an AC generator compared to the DC generator? How is the output? How does it look like? Let's see. The AC generator produces alternating current, while the DC generator produces direct current. So that's the difference. In AC generator, the output is alternating current, while the DC generator produces a direct current. This one says, what component of a DC generator converts the alternating current induced in the armature to direct current? What component of a DC generator converts the alternating current induced in the armature to direct current? The correct option is the commutator. We have already said something about the commutator and then the slip ring. So those components have their advantages. So the correct option is the commutator. The commutator converts alternating current induced in the armature to direct current in the DC generator. So the moment we replace that commutator with a slip ring, we have converted it to another function. Okay, so how do the slip ring in an AC generator function? How do the slip ring in an AC generator function? The slip ring in an AC generator provide a continuous electrical connection between the rotating armature and the external circuit, allowing AC to be transmitted. So the slip rings allows AC to be transmitted in the AC generator. What role do the brushes play in both the AC and DC generator? What role do the brushes play in both the AC and DC generator? Brushes conduct current between the rotating parts. We have the slip rings or commutator. The brushes conduct current between the rotating part and the stationary external circuit. What is the purpose of the field windings in a generator? What is the purpose of the field windings in the generator? The field windings generate a magnetic field essential for inducing voltage in the armature windings. The field windings generate magnetic field, which is essential for inducing voltage in the armature windings. So that's the function of the field windings in the generator. Why is a voltage regulator important in both AC and DC generator? Why is a voltage regulator important in both AC and DC generator? It maintains the output voltage within desired limits. It ensures a stable and efficient operation of the generator as well. Okay, this one says, what function do bearings serve in a generator? That bearing you see in a generator, what's the function? Bearing supports the rotor. Bearings allow it to rotate smoothly, and bearing reduces friction and then wear and tear. Okay, so this is our email. If you want to contact us, you just contact us through this email. This is Supreme Online Lectures. This is our homepage, and if you are our subscriber, I want to say thank you. And those who are watching us for the first time, or you have been watching us but you are not yet subscribed, this is what you will see. Please endeavor to click on that subscribe button. When you do that, it will appear to be subscribed. Thank you very much for watching. See you in our next lecture. Have a wonderful day.